Close your eyes and imagine, if you will, that you are drifting. Not falling, drifting. The way a leaf drifts when it first lets go of a branch in autumn, slowly spinning, catching the light just once before it settles gently onto the surface of the water below. That water has a name, and that name is a lake. There are lakes scattered across this planet like scattered dreams, quiet, still, and waiting. And if you were to count every single one of them, every basin filled with fresh water, every hollow carved by ancient ice or slow-moving stone, you would find that there are more than 176 million lakes on Earth. 176 million. That is more lakes than most people will ever see in a lifetime. More lakes than you could visit if you spent every waking hour traveling, from shore to shore, from one still horizon to the next. But not all of these lakes are the same. Some are small, so small you could wade across them in a few quiet steps. And some are vast beyond imagining. The largest lake in the world, by surface area, is the Caspian Sea, stretching across nearly 143,000 square miles of land between Europe and Asia. It is so large that it holds its own weather systems, its own winds, its own world, really, a world of water so wide that if you stood on one shore and looked out, you would see nothing but a horizon of calm, gray-blue stillness stretching on, as far as the eye could carry you. And deep. Some lakes are unimaginably deep. The deepest lake on Earth is Lake Baikal, tucked away in the cold, quiet wilderness of Siberia, Russia. It reaches down more than 5,315 feet, over a mile beneath the surface. A mile of water pressing down, holding secrets that sunlight has never touched. Lake Baikal is so ancient, so extraordinarily old, that it is believed to be around 25 million years old. 25 million years. Long before the first human walked the earth, long before the first bird sang, this lake was already there, already filling, already deepening, already becoming the quiet, patient body of water it is today. And because of that age, because of all those millions of years of slow, unbroken stillness, Lake Baikal holds something truly remarkable. It contains approximately 20% of the world's unfrozen fresh surface water. 1 in every 5 cups of fresh water on the surface of this planet, if you could somehow gather it all, would come from that single lake in Siberia. It is a reservoir of life, a keeper of water, untouched and unhurried. Now, close your eyes for a moment. Not permanently, just for a breath. Imagine you are standing at the edge of one of these lakes. The air is cool. The water is still, and somewhere beneath the surface, beneath the calm mirror of the sky reflected back at you, there is life. Quiet life. Patient life. Lakes are not empty places. They are ecosystems, full, thriving, teeming with living things. Some lakes are home to species found nowhere else on Earth. These are called endemic species, and they have evolved over thousands or even millions of years in isolation, shaped entirely by the unique conditions of their lake. A fish that exists only in one single lake. A snail found on no other shore. A creature so perfectly adapted to its quiet world that it never needed to go anywhere else. And the water itself, the water that fills these lakes, does not stay still forever. Lakes, like everything on this earth, are part of a cycle. Water flows in from rivers and streams, carried down from mountains and hillsides by rain and melting snow. And it flows out again, sometimes through rivers, sometimes slowly, quietly, through the ground beneath. This is the water cycle at work, an endless, gentle turning of water from sky to soil, to stream to lake, and back again. Lakes are simply a pause in that long journey, a place where water rests, if only for a while. Some lakes, though, have no outflow at all. Water flows in, but does not flow out. These are called endorheic lakes, closed basins where water accumulates over time, growing saltier and saltier as minerals dissolve into it with nowhere to go. The Great Salt Lake in Utah is one such lake. The Dead Sea, between Jordan and Israel, is another, so salty that nothing but the hardiest of microorganisms can survive in its waters. These are lakes that have turned inward, lakes that have kept everything they have ever been given. But most lakes, the ones you picture when you think of a calm, peaceful place, are freshwater lakes. And freshwater lakes are among the most important ecosystems on this planet. They provide drinking water to billions of people. They regulate local climates, cooling the air in summer and releasing warmth in winter. They filter pollutants naturally through the slow, quiet work of sediment and soil and the organisms that live within them. A single healthy lake can do more for the land around it than almost any other natural feature. It is, in many ways, the quiet heart of the landscape it sits within. So here you are, drifting again, the way you were at the very beginning. The water is still, the air is cool, and somewhere out there, across continents, beneath skies you will never see, there are 176 million lakes, each one holding its own silence, its own depth, its own slow and ancient story. You're still here, still drifting. The water beneath you is quiet, the kind of quiet that only water can hold, a silence that feels almost alive, almost breathing. And if you were to look down, gently, slowly, into the water beneath you, you might notice something. A shimmer, a faint, quiet glow, not from the sun, not from the moon, but from the water itself. Some lakes glow. It sounds like something from a dream, and in many ways it is. Certain lakes around the world are home to tiny organisms called bioluminescent algae, microscopic creatures that produce their own light. When the water is disturbed, when a wave breaks or a ripple passes, they light up, a soft, blue-green pulse, like the lake is breathing fire that does not burn. It is one of the quietest miracles on earth. A lake, glowing in the dark, asking nothing of anyone. But not every lake is glowing. Some are frozen. In the colder parts of the world, in Canada, in Scandinavia, in the high reaches of Russia, lakes freeze over in winter, forming a thick, heavy lid of ice across their surface. And beneath that ice, the water continues. It moves. It lives. It does not stop simply because the world above has gone cold and still. Life persists beneath the ice. Fish drift slowly through the dark. Microorganisms carry on their quiet work. The lake sleeps, but it does not die. Now, think for a moment about how a lake is born. It does not simply appear. It is made, slowly, patiently, over long stretches of time. Many of the lakes we know today were carved by glaciers. During the ice ages, enormous sheets of ice, miles thick, heavier than anything you can imagine, moved across the land, grinding rock, scraping valleys, and hollowing out great basins in the earth. When the ice finally retreated, it left behind depressions in the landscape. And water, as it always does, found its way into those depressions. And so a lake was born. The Great Lakes of North America, Superior, Michigan, Huron, Erie, and Ontario, were carved in exactly this way. Scooped out of the earth by glaciers, then filled, over thousands of years, by meltwater and rain. And speaking of the Great Lakes, there's something truly worth pausing over. Together, they hold about 21% of the world's surface freshwater. 21%. Imagine that. 5 lakes, sitting quietly in the middle of a continent, holding a fifth of all the fresh water that sits on the surface of this earth. Lake Superior alone is so large that it holds more water than all the other Great Lakes combined. It is a world unto itself, a vast, cold, gray expanse of water stretching across the border between the United States and Canada. But size is not the only thing that makes a lake remarkable. Some lakes are remarkable for what lies beneath them. There are lakes in the world that sit directly on top of volcanic activity, heated from below by the slow, churning heat of the earth itself. These are called volcanic lakes, and some of them are found inside the craters of volcanoes. Crater Lake, in the state of Oregon in the United States, is one such lake. It sits inside the caldera of a volcano that collapsed nearly 8,000 years ago, and its water is so extraordinarily clear, so deep and so undisturbed, that it appears almost impossibly blue. A blue so vivid it looks painted. And that clarity, that stillness, is not an accident. Crater Lake has no rivers or streams flowing into it. It is filled entirely by rain and melting snow. No outside water enters. No sediment is carried in. The lake sustains itself, quietly, from the sky alone. It is one of the purest bodies of water on the planet, and it has been that way for thousands of years. There is something deeply calming about a lake that feeds itself. A lake that needs nothing from the land around it. Just the rain, just the snow, just the slow, patient turning of the seasons. Now, let your mind wander a little further, across oceans, across continents, to a place very different from Oregon, to the high plateau of the Andes, where the air is thin and the sky is impossibly wide. There, at an altitude of over 12,500 feet above sea level, sits Lake Titicaca, the highest navigable lake in the world. It sits on the border between Peru and Bolivia, and it has been home to human civilizations for thousands of years. The Huayro people have lived on its shores, and even on floating islands made of dried reeds for centuries, building entire communities on the surface of the water itself. Lakes like Titicaca remind us that water does not only exist at the bottom of valleys. It climbs, it rises, it finds its way to the highest places on earth, and there quietly it stays. And sometimes, the water in a lake is not what you might expect. Most lakes are fresh, but some are not. We spoke earlier of endorheic lakes, the ones with no outflow, where water grows saltier over time. But there are also lakes that are acidic, lakes whose water is so filled with sulfur or other volcanic minerals that very little can survive in them. Kawah Ijen in Indonesia is one such lake, a brilliant, toxic turquoise pool sitting inside a volcanic crater, so acidic it could dissolve metal. It is beautiful, it is dangerous, and it is utterly, completely alive with chemistry. But let us return, now, to something softer, something quieter. Lakes are not only places of water, they are places of light. On clear nights, away from the glow of cities, a lake becomes a mirror, a perfect, still reflection of the sky above. Every star, every constellation, every wandering planet is doubled in the water below, as if the universe has been folded in half and laid to rest on the surface of the earth. And on nights when the aurora borealis sweeps across the northern sky, those great, shimmering curtains of green and violet light, lakes in places like Finland, Norway, and Canada reflect the display back in perfect silence. A lake beneath the northern lights is one of the most peaceful sights a human being can ever witness. Two skies, one above and one below, both glowing, both still, holding the same ancient light. So here you are again. The water is still. The sky is wide. Somewhere a lake is glowing in the dark. Somewhere a lake is frozen and dreaming beneath the ice. Somewhere a lake is reflecting the stars back into the heavens. And there is so much more to come. Mist is lifting from a lake at dawn, not all at once, but in small, quiet increments, until the water is revealed beneath a sky that is just beginning to turn gold. Lakes are not all the same shade. We've spoken of the impossible blue of Crater Lake and the toxic turquoise of Kawah Ijen. But lakes come in many colors. Some are green, stained by algae and the slow decomposition of plant matter on the floor beneath. Some are brown, tinted by tannins, the same compounds found in tea, leaching from the peat and leaves of surrounding forests. And some lakes are a shade of pink so vivid, so striking, that they look less like water and more like something spilled from a jar of watercolors. Pink lakes exist in places like Western Australia and parts of the Caribbean, and their color comes from a combination of salt-loving algae, tiny shrimp, and the particular minerals dissolved in their water. They are quiet, strange, and beautiful, and they only turn pink under certain conditions. In wetter seasons, when the water is deeper and more diluted, they fade back to blue or gray. The color is not permanent. It comes and goes like a blush. Now, if you were to wade into a lake slowly, you might notice something. The water near the surface is warmer than the water below. This is not a coincidence. Lakes, like the atmosphere, organize themselves into layers. The sun heats the surface water, and that warm water sits on top, while the colder, denser water sinks to the bottom. This layering is called thermal stratification, and it happens in most lakes during the warmer months. The boundary between the warm upper layer and the cold lower layer is called the thermocline, a quiet, invisible line drawn through the water, separating two different worlds. Fish and other creatures often gather near this boundary, where the temperatures and the oxygen levels are just right. There are lakes in the world where the lower layers are not only cold, they are completely separate from the surface. The water at the bottom does not mix with the water above. It sits there undisturbed, sometimes for thousands of years, holding gases and minerals that have no way of escaping. Lake Kivu, on the border between the Democratic Republic of Congo and Rwanda, is one such lake. Beneath its calm surface, enormous quantities of carbon dioxide and methane are dissolved in the deep water, held in place by pressure and the stillness of the layers above. It is a lake that is, in a sense, holding its breath, waiting, patient. Some lakes contain islands, and some of those islands contain lakes of their own. These are called lake islands, and the lakes within them are sometimes called recursive lakes, lakes inside lakes. It is a strange and beautiful thing to think about. A body of water surrounded by land, surrounded by water, surrounded by land again. Nature folding in on itself, quietly, without any grand announcement. One of the most famous examples is the Lake of the Mangroves in the Philippines, a small, still lake nestled inside an island, which itself sits inside a larger lake. You could spend a lifetime walking the shores of the world's lakes and never stumble upon such a place unless you knew to look for it. Beneath some lakes, the land does not simply end. It continues downward in the form of caves. There are underwater caves beneath certain lakes, openings in the rock floor where water seeps down into darkness. These subterranean passages can stretch for miles, connecting one lake to another, or to an underground aquifer far below the surface. They are places where light has never reached, where the water moves in slow, silent currents, carrying minerals and sustaining ecosystems that have never seen the sun. The edge of a lake, where the water meets the land, is called the littoral zone, and it is one of the richest and most alive parts of any lake. Reeds grow here. Cattails and water lilies float on the surface. Frogs call out in the evenings. Dragonflies hover just above the water, their wings catching the last light of the day. Birds wade through the shallows, picking their way carefully through the mud and the roots. The littoral zone is where the lake breathes, where it exchanges gases with the air, where it interacts with the land, where so much of its life begins and ends. And when autumn comes, something happens to many lakes. They begin to mix. The thermal layers that separated the warm surface water from the cold water below start to break down as the surface cools. The water turns over slowly, and nutrients from the deep are carried upward to the surface. This process is called turnover, and it happens twice a year in many lakes, once in autumn and once again in spring. It is the lake's way of renewing itself, of stirring its own depths, of bringing what has been buried back into the light. There is something comforting in that. A lake that renews itself. That does not need anyone to stir it. It simply turns when the time is right and begins again. Lake Tanganyika stretches along the border between Tanzania, Congo, Burundi, and Zambia, and is the second deepest lake in the world, after Baikal. It reaches down over 4,800 feet, and is believed to be between 9 and 13 million years old. It has become home to an extraordinary number of unique species. Over 1,500 species of cichlid fish alone have evolved in its waters, each one adapted to a slightly different niche within the lake. It is, in its own quiet way, one of the great centers of biodiversity on this planet. In lakes like Tanganyika, the sheer number of endemic species is staggering. The process by which new species arise within an isolated body of water, evolving, diversifying, filling every available role in the ecosystem, is called adaptive radiation. It is one of the most remarkable phenomena in all of biology, and lakes are among the best places on Earth to witness its results. A single ancestral fish species, arriving in an empty lake millions of years ago, can give rise to hundreds of distinct species over time, each one shaped by the lake, each one belonging to it, each one a testament to the quiet, patient power of time. So here you are. The water is still. The shores are alive with the quiet sounds of evening. Beneath you, layers of water hold their secrets. We have wandered far, from the deepest trenches of Baikal to the pink shores of Western Australia, from the frozen lakes of winter to the glowing waters of the tropics. But there is a place we have not yet visited, a place where the water is not deep and not ancient and not particularly still, but where it is, in its own way, one of the most important bodies of water on Earth. Think of a wetland, not quite a lake and not quite a river, something in between, a marshy, boggy, half-submerged stretch of land where the water sits just beneath the surface, seeping through mud and root and grass. Wetlands are sometimes called the kidneys of the earth because they filter water as it passes through them, removing pollutants, slowing the flow of floodwater, and returning clean water to the rivers and lakes and oceans beyond. Many wetlands are, in fact, connected to lakes, fed by them, or feeding into them, and together they form some of the most productive ecosystems on the planet. Now, let's turn our attention back to the lakes themselves, and to something that happens on their surfaces, quietly, without any fuss. In the spring and summer, when the sun is long and warm, algae blooms across the surface of many lakes. A thin, green film, spreading slowly outward like a blanket being laid across the water. In small amounts, algae is perfectly natural. It is food for fish and insects, and part of the lake's own rhythm of life. But sometimes, when there is too much nitrogen or phosphorus in the water, often carried in by runoff from farms and cities nearby, the algae can grow out of control. This is called an algal bloom, and it can choke the surface of a lake, blocking out sunlight and starving the water beneath of oxygen. It is one of the quietest threats a lake can face, and it is happening in lakes all around the world. There is something sad in that, a lake slowly being smothered by its own surface. But there is also hope, because people are learning. Scientists are studying these blooms, and communities are finding ways to reduce the flow of nutrients into the lakes they depend on. A lake can recover, if given the chance. It is a patient thing. After all, it has been waiting for millions of years. It can wait a little longer. Now, close your eyes again, just for a moment, and think about sound. What does a lake sound like? In the middle of the night, far from any road or town, a lake is almost perfectly silent. But not quite. There is the soft lap of water against stone, the occasional creak of ice in winter, the distant call of a bird settling onto the water in the dark. And sometimes, on very still nights, you can hear the lake itself shifting, a deep, low murmur, like the earth breathing beneath you. Lakes are not silent. They are simply very, very quiet. And beneath that quiet, something remarkable is happening, something that has been happening for as long as there have been lakes on this earth. Sediment is falling. Tiny particles of sand and silt and clay, drifting down through the water like snow falling in slow motion, settling onto the lake floor layer by layer, year by year, decade by decade. Over thousands of years, these layers build up into a record, a detailed, unbroken chronicle of everything that has happened in and around the lake. Scientists call these layers sediment cores, and they can be extracted and studied like pages of a book. The pollen trapped in an ancient layer can tell us what plants were growing nearby 10,000 years ago. Volcanic ash can mark the year of an eruption. Changes in the type of sediment can reveal shifts in climate, shifts in the landscape, shifts in the life of the lake itself. A single sediment core from a deep lake can hold tens of thousands of years of history, all of it preserved, all of it waiting to be read. It is a humbling thing to think about. A lake keeping records, writing its own history, one quiet layer at a time, without anyone asking it to. Now, travel with me, gently, slowly, to the continent of Antarctica, to a place where the ice is so thick, so ancient, so impossibly heavy that it is pressed down on the land beneath for millions of years. And beneath that ice, far beneath, hidden from the surface world entirely, there are lakes. Subglacial lakes, they are called, and they are one of the strangest discoveries ever made on this planet. Lake Vostok, buried beneath nearly 2.5 miles of Antarctic ice, is the largest of them. It has been sealed away from the surface for an estimated 15 to 25 million years, and the water within it has not seen sunlight in all that time. And yet, scientists believe it may still harbor life. Microorganisms that have survived in complete darkness, in near-freezing temperatures, feeding on minerals and chemical reactions alone. If life can exist in a place like Lake Vostok, then it raises a quiet, extraordinary question. Could it exist somewhere else, too? On another world? Beneath the ice of a moon, orbiting a distant sun? A lake beneath the ice of Antarctica, possibly holding life that has not seen the sun in 20 million years. It is almost too large a thought to hold while you're trying to sleep. So let it go. Let it drift away from you, the way the mist drifts from the surface of a lake at dawn. And here, closer to the surface, closer to the world, think about the creatures that live on the skin of a lake. Not beneath it, on it. There are insects, like water striders, that walk across the surface of a lake without breaking through. They are held up not by any special strength, but by the surface tension of the water itself. A thin, invisible film that holds the surface together like a membrane stretched across a drum. It is a delicate thing, this film, and yet it is strong enough to support the weight of an insect, again and again, across the still and quiet surface of a lake. So here you are. The water is still. The sediment is falling, slowly, in the dark beneath you. Somewhere, a lake is keeping its own quiet history. Somewhere, beneath miles of Antarctic ice, a lake is dreaming in the cold and the dark. And somewhere on the surface of the water closest to you, something small and light is walking across the skin of the lake, asking nothing, disturbing nothing, simply being. You are deeper now, deeper into the night, deeper into the quiet. The water around you has settled into something close to stillness. Not the stillness of something that has stopped, but the stillness of something that has always been moving, just too slowly for you to notice. And somewhere above you, far above, where the sky is wide and dark and dusted with stars, birds are flying. Not the birds of daytime, with their bright calls and their restless wings. These are the quiet ones, the ones that travel at night, navigating by the stars and the pull of the Earth's magnetic field, moving across vast distances in the dark. Many of them are heading toward lakes. Lakes are among the most important resting places for migratory birds, wetlands and shorelines where they can land, drink, feed, and gather strength before continuing on their long journey. Flamingos gather in the thousands on the salt lakes of East Africa. Swans descend onto the still waters of northern Europe in great, silent flocks. Ducks and geese crowd the surfaces of lakes across North America and Asia, filling the water with their quiet, bobbing presence. Lakes are waypoints on the longest journeys birds make, bridges between one season and the next, between one continent and another. Now, think about what happens beneath the surface of a lake as the light fades, not just at night, but as you descend. The deeper you go, the less light reaches you. And with less light comes less oxygen. Most of the oxygen in a lake is produced near the surface, where sunlight drives the process of photosynthesis in algae and aquatic plants. Deeper down, the water grows darker, and the oxygen grows thinner. There are layers in a lake where very little life can survive, not because the water is poisonous, but simply because there is not enough air to breathe. Scientists call this the oxygen-depleted zone, and in some lakes it stretches for hundreds of feet beneath the surface, a vast and quiet emptiness where only the hardiest organisms can exist. But life finds a way. It always does. Even in the darkest, most oxygen-starved corners of a lake, there are creatures, bacteria, mostly, that do not need oxygen at all. They feed on the slow decay of organic matter that drifts down from above, breaking it down through chemical processes that require no light and no air. They are quiet, invisible, and essential. Without them, the nutrients locked in the deep would never be released back into the water above. Lakes, it turns out, do not last forever. Some lakes are shrinking. Slowly, over decades and centuries, they are losing water, to evaporation, to changes in rainfall, to the diversion of rivers that once fed them. Lake Chad, in the heart of West Africa, is one of the most striking examples. 50 years ago, it was one of the largest lakes on the continent, a vast, shallow body of water stretching across parts of Chad, Niger, Nigeria, and Cameroon. Today, it has shrunk to a fraction of its former size. The water has been drawn off for irrigation, and the climate has shifted, bringing less rain to the region. It is a lake that is disappearing, slowly, before our eyes. And it is not the only one. There is something quietly sorrowful in that. A lake fading. A body of water that has been there for thousands of years, shrinking little by little, like a breath being slowly exhaled. But lakes have also appeared where none existed before. In the Arctic, as the permafrost, the layer of ground that stays frozen year-round, begins to thaw with rising temperatures, pockets of water collect in the soft, soggy earth. These new lakes, called thermokarst lakes, are appearing across Alaska, Siberia, and northern Canada at an increasing rate. They are young lakes, born from the warming of the world, and they are reshaping the landscapes of the far north in ways that scientists are only beginning to understand. So lakes disappear, and lakes are born. The world is not static. It is always turning, always changing, always finding new ways to hold water. Now let's think about something small, something easy to overlook if you're not looking for it. Beneath the surface of many freshwater lakes, clinging to the muddy floor or nestled in the gravel of a riverbed, there are mussels. Freshwater mussels, quiet, slow-moving creatures that spend their entire lives in one place, filtering water through their bodies, drawing in sediment and tiny organisms, and returning the water cleaner than it was before. A single freshwater mussel can filter hundreds of gallons of water in a single day. And in a healthy lake, there may be millions of them, working together in complete silence, purifying the water that everything else depends on. They are, in their own unhurried way, among the most important creatures in any lake. And yet freshwater mussels are among the most threatened species on Earth. Many of them are disappearing, lost to pollution, to habitat destruction, to the introduction of invasive species that outcompete them for food and space. It is another quiet loss, another small, invisible thread being pulled from the web of life that holds a lake together. But there is beauty here too, because in the lakes and rivers where freshwater mussels still thrive, the water is clean. It is clear. It is alive. A lake with healthy mussels is a lake that is working, doing what lakes have always done, which is to hold water, to clean it, and to give it back to the world. And finally, before we drift any further into this hour, there is one more thing worth knowing about lakes, something you might feel if you were to sit beside one on a summer evening. Lakes affect the weather around them. A large body of water holds heat longer than the land around it. It warms more slowly in summer and cools more slowly in winter. This means that the land near a lake tends to be milder than the land farther away. Summers are a little cooler. Winters are a little warmer. The lake smooths out the sharp edges of the seasons, creating a softer, gentler climate in its shadow. Cities that sit beside large lakes, like Chicago, beside Lake Michigan, or Geneva, beside its famous lake in Switzerland, enjoy this effect every year, though most of their residents have never stopped to wonder why their winters feel just a little less brutal than they might otherwise be. So here you are. The birds are settling onto the water somewhere above you, folding their wings, resting. The mussels are filtering, quietly, in the mud below. The lake is warming the air around it, softening the night. And somewhere, a new lake is forming in the thawing ground of the Arctic. And somewhere else, an old lake is shrinking, inch by inch, back into the earth from which it came. You are here, drifting, listening, letting the world outside grow a little quieter with each passing minute. And if you're still awake, that is all right. The lake does not mind. It has been here long before you, and it will be here long after. All it asks is that you stay a little longer. We have spoken of the creatures that live in lakes, the fish, the mussels, the bacteria in the deep. But there is one creature we have not yet mentioned, and it is perhaps the most important of them all. You cannot see it with your eyes. It is too small for that. But it is everywhere, floating in the upper layers of almost every lake on Earth, drifting in the sunlight like dust motes in a beam of light through a window. It is called phytoplankton, and it is responsible for producing a significant portion of the oxygen that we breathe, not just in lakes, but on this entire planet. Phytoplankton in the world's oceans and freshwater bodies produce roughly half of all the oxygen in Earth's atmosphere. Half. It is a quiet miracle, happening on a scale so vast and so invisible that most people never think about it. Every breath you take, every single one, owes something to these tiny, drifting organisms floating in lakes and oceans, turning sunlight into air. Now, lakes have meant something to people for a very long time. Long before cities were built, long before roads were laid, people gathered at the edges of lakes. They drank from them. They fished in them. They looked out across them and saw something that stirred something deep and old inside them. A sense of wonder, perhaps, or of smallness, or of connection to something larger than themselves. And so they made the lake sacred. Across cultures and continents, lakes have been the homes of gods, the dwelling places of spirits, the sites of ancient rituals and prayers. Lake Como in Italy has been revered since Roman times. The sacred lakes of Tibet sit at the roof of the world, visited by pilgrims who walk for weeks across the high plateau to reach their shores. And in the myths of countless peoples, from the Celts of Ireland to the indigenous nations of North America, lakes are portals, doorways to another world, another time, another layer of reality, hidden beneath the still and shimmering surface. But not everything that has come to lakes has been welcome. In recent centuries, human beings have introduced species into lakes where they do not belong. Fish, plants, and invertebrates carried in on boats or released deliberately, sometimes with good intentions, sometimes carelessly. These are called invasive species, and they can devastate the ecosystems of a lake. The zebra mussel, originally from the rivers of Eastern Europe, has spread across lakes in North America, clogging water intakes, smothering native mussels, and disrupting the food web. The Asian carp, massive and fast-breeding, threatens to overwhelm the Great Lakes if it finds its way in. An invasive species in a lake is like a thread pulled too hard in a tapestry. It can unravel the whole thing, quietly, from within. And yet lakes persist. They adapt. They find new equilibria, even when the world around them is changing. It is one of the things that makes them so enduring, this quiet, patient ability to absorb what comes and to carry on. Now, think about winter again. Not the frozen stillness we spoke of earlier, but something that happens above the lake, in the sky, when the air is cold and the water is not yet fully frozen. In certain places, near the shores of the Great Lakes, for instance, or beside large bodies of water in other parts of the world, the lakes produce their own weather. Cold air moves across the relatively warm surface of the water, picking up moisture as it goes, and when it finally reaches the colder land beyond the shore, that moisture falls as snow. Heavy, relentless snow. This is called lake effect snow, and it can dump enormous amounts of snowfall on communities that sit downwind of a large lake. Cities like Buffalo, New York, and parts of Ontario in Canada receive some of the heaviest snowfall in the world because of this effect. The lake itself is the storm. It is feeding the sky. There is something almost alive in that. A lake making weather, breathing moisture into the air, shaping the clouds, dropping snow on the land below. A lake that is not only holding water, but giving it back to the sky in a new form. And beneath all of this, beneath the snow, beneath the ice, beneath the storms and the seasons, the lake floor is slowly, imperceptibly changing. Lakes are not flat at the bottom. They have their own geography, ridges and valleys, mud flats and rocky outcrops, hollows where the sediment collects and slopes where it slides away. And over thousands of years, this geography shifts. Rivers deposit new land at the edges. Sediment fills in the shallows. The lake grows smaller or changes shape, or, in some cases, splits into two. It is geology at work, and it is happening beneath every lake on Earth, right now, as you listen. Now, there is another quiet role that lakes play, one that is only beginning to be understood. Lakes are stores of carbon. When plants and algae die in a lake, they sink to the bottom, and much of the carbon they contain becomes trapped in the sediment, locked away from the atmosphere. In this way, lakes act as carbon sinks, holding carbon that might otherwise be released into the air as carbon dioxide. Healthy lakes, with their rich ecosystems and their steady accumulation of organic matter on the floor, are quietly helping to keep the planet's climate in balance. It is another invisible contribution, another silent service that lakes provide to the world above them. And finally, before we close this hour, let us return to something simple, something human. People swim in lakes. They have always swum in lakes. Children wade in the shallows on summer afternoons, the water cool against their skin, the sun warm on their faces. Swimmers glide out across the surface in long, quiet strokes, watching the shore grow smaller behind them. And sometimes, in the middle of a very large lake, a swimmer stops, floats on their back, looks up at the sky, and for a moment, just a moment, the lake and the swimmer and the sky are all one thing. Still, quiet, held together by nothing more than water and air and the soft, slow turning of the earth. It is a small thing, but it is one of the oldest things human beings have done. To come to the water, to let it hold them, to float. You have crossed a threshold, whether you knew it or not, gently, without announcement, and now we are deeper into the night, deeper into the quiet. The lake does not mark the hour. It simply continues the way it has always continued, holding its water, holding its silence, holding the dark sky above it like a palm turned upward. And beneath the surface, if you could see it, if you had eyes that worked in the dark, there is movement, not the slow, drifting movement of sediment falling, which we spoke of before. This is something faster, something deliberate. Tiny creatures, no bigger than a grain of sand, are swimming upward. They are called zooplankton, microscopic animals that feed on the phytoplankton floating in the sunlit layers above. During the day, they hide in the deeper, darker water, out of sight of the fish that would eat them. But at night, when the light fades and the danger passes, they rise. Millions of them, in every lake, making the same journey every single night, up toward the surface to feed, and back down again before dawn. It is one of the largest migrations on Earth, and it happens every night, in silence, in almost every lake and ocean on the planet. There is something almost comforting in that. A rhythm, a pulse. The lake breathing in and out, over and over, in the dark. Now, let us travel, one more time gently, to Africa, not to Tanganyika this time, which we visited before, but to another lake along the Great Rift. Lake Malawi, the third of the African Rift lakes, stretches long and narrow along the border between Malawi, Mozambique, and Tanzania. And like its neighbor to the north, it is a place of extraordinary biological richness. Lake Malawi is home to more species of cichlid fish than any other lake on Earth. Over 1,000 distinct species, each one evolved within the lake itself, each one a variation on a theme that has been playing out for millions of years. Some of these fish are so small they fit in the palm of your hand. Others are large and predatory, lurking in the deeper waters. But all of them, every single one, belong to this lake. They are found nowhere else. It is a testament to what a single, isolated body of water can produce, given enough time and enough stillness. And speaking of stillness, think about what happens to a lake at night. During the day, the sun heats the surface, and the water stays relatively warm. But at night, when the sun is gone, the surface of the lake begins to cool. It radiates heat slowly into the sky above, and as it does, the air just above the water grows cooler too. This thin layer of cool air sits close to the surface, and it is often very still, because cool air is denser than warm air, and dense air does not move easily. This is why lakes are often so calm at night. The air above them has settled into a quiet, heavy stillness, and the water beneath mirrors that stillness perfectly. A lake at night is not just dark. It is calm in a way that the same lake, in the same place, may not be during the day. Now, there is something else that falls into lakes, something that most people never think about. Leaves. In the autumn, when the trees around a lake shed their leaves, many of those leaves drift down onto the water and are carried slowly to the bottom. They settle into the mud, and over time they decompose, broken down by bacteria and fungi and the slow work of the water itself. But before they disappear entirely, they release nutrients back into the lake. Nitrogen, phosphorus, carbon. The same elements that the trees drew up from the soil through their roots are now being returned to the water. This is called a lochthonous input, a quiet, seasonal gift from the land to the lake. It is one of the ways in which a lake and the forest around it are connected, feeding each other in a cycle that has been turning for as long as both have existed. And beneath the mud, far beneath, in the oldest layers of sediment, there are fossils. Not the great bones of dinosaurs, but something smaller, quieter. The fossilized remains of tiny organisms, pollen grains, diatoms, the shells of microscopic creatures, preserved in the sediment for thousands or even millions of years. These fossils tell us stories about the past. They show us what the climate was like long ago, what plants were growing, what the lake itself looked like when it was younger. Some lake beds hold fossils that are tens of millions of years old, records of a world so different from our own that it is almost impossible to imagine. And yet the fossils are there, waiting in the mud, patient as the lakes themselves. Now, think about the color of a lake one more time. We have spoken of blue lakes and green ones and pink ones and brown ones. But why is a lake blue at all? The answer has to do with light. Sunlight is not one color. It is all colors, mixed together. When it enters the water, different wavelengths of light are absorbed at different rates. Red light is absorbed quickly, near the surface. Blue light travels deeper, penetrating farther into the water before it too is absorbed or scattered. So when you look at a deep, clear lake, you're seeing the color that the water lets through, the blue that has traveled the farthest, the color that the depth of the lake allows to survive. A deeper lake will often appear bluer than a shallow one, simply because it holds more of that long-traveling light. It is a quiet thing, the color of water. It is not painted on. It is not added. It is simply what is left after everything else has been taken away. And now, one more lake, before we drift any further. Lake Winnipeg, in the Canadian province of Manitoba, is not deep. It is not ancient in the way that Baikal or Tanganyika are ancient, but it is vast, one of the largest freshwater lakes in North America, stretching nearly 260 miles from north to south, and it plays an extraordinary role in the landscape around it. Lake Winnipeg is the endpoint of a massive watershed, a network of rivers and streams that drain water from as far away as the Rocky Mountains in the west and the hills of Montana and North Dakota in the south. Water from 9 Canadian provinces and 4 American states eventually finds its way, through rivers and tributaries, into Lake Winnipeg. It is a gathering place, a place where the water of an entire continent comes together, slowly, quietly, before passing on a Hudson Bay and eventually to the sea. And that is, in many ways, what lakes are. Gathering places. Not endpoints, but waypoints. Places where water pauses on its long journey from sky to sea, collecting itself, holding still for a while, before moving on. We spoke, not long ago, of Lake Chad, a lake that is slowly disappearing from the face of the earth. But it is not the only lake to have suffered such a fate. There is another, perhaps even more striking, on the other side of the world. The Aral Sea, which sits between Kazakhstan and Uzbekistan in Central Asia, was once one of the largest lakes on the planet. 50 years ago, it stretched across nearly 26,000 square miles, a vast, calm inland sea, teeming with fish, supporting the livelihoods of thousands of people who lived along its shores. But in the 1960s, the Soviet Union diverted the two rivers that fed it, the Amu Darya and the Sir Darya, to irrigate cotton fields in the surrounding desert. The water stopped coming, and the lake began to die. Today, the Aral Sea has lost more than 90% of its water. What remains is a skeleton of salt flats and stranded fishing boats, rusting in the dust where the shoreline used to be. It is one of the greatest environmental disasters in human history, and it was made entirely by human hands. There is something deeply sobering in that. A lake destroyed not by nature, but by choice. But let us turn now to something older, something that has been swimming in lakes long before human beings walked the earth. The sturgeon is one of the most ancient fish alive today. Some species of sturgeon have remained essentially unchanged for over 100 million years, longer than the dinosaurs have been gone. They are living fossils, these fish moving through the deep waters of lakes and rivers with a slow, prehistoric grace. They are found in lakes across the northern hemisphere, in the Caspian Sea, in Lake Baikal, in the rivers and lakes of North America and Europe. And like so many ancient things, they are in danger. Overfishing and habitat destruction have pushed many sturgeon species toward extinction. But they persist, as they have persisted for 100 million years, moving through the dark water with patience and purpose. Now, think about what a lake does at night. Not just cooling, not just growing still, but releasing something into the air. Beneath the surface of many lakes, in the oxygen-depleted sediment at the bottom, organic matter is slowly decaying. And as it decays, it produces methane, a gas that rises slowly through the water and escapes into the atmosphere when it reaches the surface. In some lakes, this release of methane is so significant that it contributes meaningfully to the greenhouse gases in the air above. And on cold nights, when the surface of the lake is calm and the air is still, you can sometimes see the methane bubbling up, small, quiet pops on the surface of the water, like the lake exhaling. It is not something you would notice unless you were watching very closely, but it is happening in lakes around the world every night. Let us travel now, far from the cold nights of the north, to the equator, to South America, to the Amazon River, which is not just a river, but an entire world of water. During the wet season, the Amazon floods enormously. The river spills out across vast stretches of flat land, and the landscape transforms. Forests become lakes, fields become seas, and the water stretches in every direction as far as the eye can see. These seasonal floodplain lakes are among the most productive ecosystems on Earth. Fish spawn in them. Birds nest in the flooded trees above them. Insects swarm across their surfaces. And when the water recedes, months later, it leaves behind rich, fertile soil, deposited by the flood, nourishing the land for the next growing season. It is a cycle as old as the river itself, a lake that is born every year and disappears every year and is reborn again. Now, there's a question that very few people think to ask. How deep have human beings actually gone into a lake? Lake Baikal, which we visited at the very beginning of this journey, has been explored by submersibles that have descended to its full depth, over 5,300 feet. Scientists aboard these vessels have filmed creatures that live in the absolute darkness at the bottom, organisms found nowhere else, thriving in the cold and the pressure and the silence. It is a reminder that even in a lake, a body of water that most people think of as familiar, as tame, as something you might swim across on a summer afternoon, there are places that are as strange and as unreachable as anything on the ocean floor. A lake freezes from the surface down. When the air grows cold enough, the water at the very top of the lake begins to lose heat. It cools, and as it cools, it becomes denser until it begins to crystallize. Ice forms on the surface first, a thin sheet that spreads slowly outward from the edges, growing thicker day by day as the cold deepens. Beneath this growing lid of ice, the water remains liquid, insulated from the cold above, held at a temperature just above freezing. This is why fish and other creatures can survive a frozen winter. The ice above them is not a tomb. It is a blanket. Lake Victoria, in East Africa, is the largest lake on the continent by surface area. It sits at the junction of 3 countries, Kenya, Tanzania, and Uganda, and it is, for millions of people, the center of everything. Fishing communities have lived on its shores for generations, drawing their livelihoods from its waters. It is a source of drinking water, a source of food, a source of life. And it is also a lake that has come and gone before. Scientists believe that Lake Victoria actually dried up completely at least once in its history, during a period of severe drought, and then filled again when the rains returned. A lake that died and was reborn. A lake that knows how to begin again. The water in a lake does not stay forever. We spoke, early in our journey, about how lakes are part of the water cycle, water flowing in, water flowing out. But have you ever wondered how long a single drop of water actually stays in a lake before it moves on? The answer depends on the lake. In a small lake with a river running through it, water might pass through in days or weeks. In a vast, closed lake like Baikal, where the water barely moves and the outflow is slow, a single drop of water might remain for thousands of years before it finally finds its way out. This is called the residence time of a lake, and it varies enormously from days to millennia. Some lakes hold their water like a breath that is never quite exhaled. And how does that water eventually leave? In many cases, it does not flow out through a river at all. It simply disappears. It evaporates, rising from the surface of the lake as invisible vapor, lifted into the air by the warmth of the sun, joining the atmosphere and drifting away on the wind. Evaporation is one of the quietest processes on Earth. You cannot see it happening. You cannot hear it. And yet it is happening constantly, in every lake, every day, a slow, silent giving back of water to the sky. On a warm, dry day, a large lake can lose millions of gallons of water to evaporation without anyone noticing at all. Now, most lakes respond to the weather above them, to rain and wind and sun. But some lakes respond to something else entirely. Tidal lakes are lakes that are connected to the ocean, or close enough to it, that the gravitational pull of the moon causes their water levels to rise and fall with the tides. They are rare, but they exist. Quiet lakes that breathe in rhythm with the moon, swelling and receding on a schedule that has been turning since the Earth first began to spin. To sit beside a tidal lake at night is to feel, in a very small way, the pull of the moon, not as a force you can see, but as a slow and patient movement of water that mirrors the movement of the sky above. And in many lakes, particularly in the cooler forests of the north, fallen trees play a role that is easy to overlook. When a tree falls into a lake or along its shore, it does not simply rot away. It becomes a habitat. Moss grows on it. Insects lay their eggs beneath the bark. Fish shelter in hollows where the wood has softened and begun to decay. Over years and decades, the fallen tree becomes a small ecosystem of its own, a quiet, slow-crumbling world within the world of the lake. Scientists call this woody debris, and they have found that lakes with more of it tend to be healthier, more biodiverse, more alive. A fallen tree in a lake is not a dead thing. It is the beginning of something. Most lakes on Earth have no name at all. They are too small, too remote, too unremarkable to have ever been noticed by the people who name things. They sit quietly in valleys and hollows and mountain basins, known only to the animals that drink from them and the birds that land on them. Unnamed lakes, unvisited lakes, lakes that have been holding water for thousands of years without anyone ever stopping to look. Just before sunrise, when the sky is still dark but the air has begun to change. On a still night, when the lake has been cooling for hours, the surface of the water is often warmer than the air just above it. And when warm water meets cold air, something happens. The moisture in the water begins to rise, not as rain, but as a thin, delicate mist. It curls upward from the surface in slow, ghostly tendrils, hovering just above the water like breath on a cold morning. This is fog, lake fog, and it is one of the most beautiful sights a lake can offer. It does not last long. As the sun rises and the air warms, it burns away, and the lake is revealed again, clear and still beneath a brightening sky. But for those few quiet minutes, the lake and the mist are one thing, indistinguishable, merged, breathing together in the dark. There are deep lakes on every continent, but the deepest lake in the Americas is not one that most people have heard of. It is Lake O'Higgins, also known as Lake San Martin, sitting on the border between Argentina and Chile in the far south of Patagonia. It reaches down over 2,900 feet, not as deep as Baikal, but deeper than almost anything else in the Western Hemisphere. Its water is so extraordinarily clear, so free of sediment, that it has an almost supernatural quality, a blue so pure and so cold that it looks less like water and more like a window into the earth itself. Of all the water on this planet, lakes hold only a very small fraction. The oceans contain roughly 97% of all the water on Earth. Lakes, rivers, and swamps together hold less than 1%. And of that tiny fraction, most of it is salt water. Fresh water, the kind you drink, the kind that sustains terrestrial life, is rarer still. Lakes are precious not because they are abundant, but because they are so necessary and so fragile. And here is something stranger still. As far as we know, as far as any human being has ever been able to determine, there are no lakes on any other planet or moon in our solar system. Not yet confirmed, at any rate. There may be oceans beneath the ice of Europa, one of Jupiter's moons. There may be lakes on Titan, one of Saturn's moons, but they would be lakes of liquid methane, not water. A lake of water, like the ones we have been speaking of all night, appears to be something unique to this planet, something that has not yet been found anywhere else in the universe. Every lake on Earth is, in that sense, irreplaceable, and yet the lake you are drifting on tonight is not the same lake it was 100 years ago. The water has changed. The fish have changed. The sediment on the bottom has shifted, and yet we still call it the same lake. We give it the same name. We treat it as a continuous thing, a single, unbroken body of water, even though almost nothing in it is the same as it was a generation ago. It is like an old ship, rebuilt plank by plank over the centuries, until none of the original wood remains. Is it still the same ship? Is it still the same lake? The answer, perhaps, is that a lake is not its water. It is its shape, its basin, its place in a landscape. The water flows through it, the way breath flows through lungs, always changing, always renewing, but the shape remains. In some of the oldest lakes on Earth, in Baikal, in Tanganyika, in the ancient lakes of the Rift Valleys, there are fish that have been isolated for so long that they have become entirely unique. Not just different species, but populations so cut off from the rest of the world that they have evolved along paths no other fish on Earth has taken. A single fish in a single lake, adapting to conditions that exist nowhere else, developing colors, behaviors, feeding habits that are entirely its own. These fish are living records of isolation, living proof of what happens when a creature is given enough time and enough stillness. Lakes are among the last truly wild places left on Earth. Many of them have never been touched by roads or buildings or boats. They sit in remote mountains, in deep valleys, in places where the land is too difficult or too inhospitable for human beings to settle. And in those places, the water remains as it has always been, clean, cold, undisturbed. A lake that has never been polluted. A lake that has never been drained. A lake that has simply been holding its water, quietly, for longer than anyone can remember. There's a way of seeing a lake that human eyes cannot. Infrared cameras, cameras that detect heat rather than light, show lakes in a completely different way. In infrared, the surface of a lake glows with the heat it has absorbed during the day. The edges glow differently from the center. The areas where warm water rises from below shine brighter than the areas where the water is cold. It is a portrait of a lake's inner life, its temperature, its currents, its hidden movements, made visible for the first time. A lake seen in infrared is a lake seen honestly, all of its secrets laid bare in color. Ancient civilizations understood something that modern people often forget, that lakes are the best places to build. They provide water. They provide food. They moderate the climate. They offer protection, because an enemy approaching across open water can be seen long before it arrives. Cities have sprung up beside lakes for as long as there have been cities at all. The earliest settlements in Mesopotamia were built along the edges of marshes and shallow lakes. The Aztecs built Tenochtitlan, the great capital of their empire, on an island in the middle of a lake. Lake settlements exist on every continent, stretching back thousands of years. Lakes did not just sustain civilization. In many cases, they made it possible. The surface of a calm lake is one of the smoothest naturally occurring surfaces on Earth. Smoother than glass, in many cases, flatter than almost anything made by human hands. On a perfectly still night, with no wind and no rain, the surface of a large lake can be so even, so undisturbed, that it becomes almost impossible to tell where the water ends and the air begins. The horizon disappears. The sky and the lake merge into a single, seamless stillness. It is a disorienting thing, if you think about it too hard. So do not think about it too hard. Simply let it be. Scientists and engineers have, in recent decades, begun to consider lakes as potential landing sites for spacecraft returning to Earth. A large, calm lake offers a smooth and predictable surface, better, in some ways, than the ocean, which is never truly calm. The idea is still mostly theoretical, but it is a measure of how remarkable a lake's surface can be, smooth enough, stable enough, reliable enough, that human beings have looked at it and seen not just water, but a runway. And now, right now, at this very moment, as you listen, somewhere on Earth, a lake is perfectly still. Not almost still, not nearly still, perfectly. The surface is glass. The air above it is motionless. No wind, no rain, no creature stirring the water. Just stillness, absolute, complete, and utterly silent. It may be a lake you have never heard of, in a place you will never visit. It may have no name, but it is there. It is real, and it is holding the night in its water, the way it has held every night that has come before. And that brings us to the end of our story and our journey. Our last fact, the 100th, the final quiet truth about lakes, delivered not with any fanfare, but simply the way a lake delivers everything. Gently, patiently, without hurry. You have been drifting for quite a while on the water and stillness and the slow turning of the world. And the lake is still here. It was here before you began listening, and it will be here long after you have closed your eyes. Let the night carry you down into deep, cool water of sleep. Let the water hold you. Let the silence hold you. Let the dark, quiet, ancient world of lakes hold you, the way it has held the world for millions and millions of years.